Okay, same as what we did with the last problem. Let's start this one by figuring out where it is centered, and I'd like to think it's obvious, but basically it's your x factor is, well, that's a TV show too, isn't it? But this one is centered at, let's make that look like an E, centered at x equals, well, horizontal shift, so x equals 1. All right, that's the easy part. And now we're going to kind of shift gears, and we're going to do the ratio test again. I'm not going to write the words ratio test over on the side. It's kind of intuitive at this point. So the limit as n approaches infinity of 10 to the n plus 1. I'm going to go ahead and kind of pretend like this is in the numerator because it really is, right? So x minus 1 to the n plus 1 over n plus 1 factorial divided by 10 to the n, x minus 1 to the n over n factorial. Okay, cool. Here we go. Let's keep going. This is the limit as n approaches infinity of 10 to the n, 10, x minus 1 to the n, x minus 1 over n factorial, n plus 1. I'm doing that because I know I'm going to need to cancel that one out. All that's in bars. And then n factorial over 10 to the n, x minus 1 to the n. There are patterns to this that emerge, and you can start canceling things out early if you know what to look for. So that and that, cancel that and that, cancel that and that, cancel, and we have this. And we are going to have 10 x minus 1 over n plus 1. All right. As with the last problem, we are looking at the limit as n approaches infinity. Okay, that's great. Therefore, my limit, I'm going to leave a little gap here, my limit as n approaches infinity should only involve stuff that has the letter n in it, the variable n in it, right? And that kind of takes everything out of the numerator except an understood 1 that needs to be put there so it's understood. And the x and the 10, we can factor them out. Now, could I leave the 10 up here? Sure. Go for it. It's fine. It's really not going to affect your life, and you'll see why in a minute. 10 and then x minus 1 goes here. Technically, it's an absolute value because this could be negative, right? This won't be, but this could be negative. But as n approaches infinity, this becomes 0. So even though it might be slightly unnecessary, for the sake of explanation, I will write times 0. And I'm writing the obvious here, so 0. Duh, right? Okay. Now, here's the thing. The ratio test shows convergence when this is true, when it's less than 1. All right? Fine. It's less than 1. It is less than 1 regardless of what x value I plug in. This x factor is irrelevant. It's always going to converge. So therefore, my radius of convergence is infinity. All right, let's talk about what that means. From where it is centered, I could go forever to the left and forever to the right, and this will always converge. As long as I'm actually going all the way to infinity, this will converge upon the function that it is approximating. Okay, what is my radius of convergence? Well, I'm going forever to the left and forever to the right, and I don't need to test the endpoints because it's infinity.